All right, good day and welcome to our class for today. Of course, the course on the board is nothing but Machine Design 1, and we are going to be starting with simple stresses and strain. Now, the first question we are going to be looking at is as follows. It said a coil chain of a crane required to carry a maximum load of 50 kilonewton is shown below. So this is the coil chain of the crane. Now, it has a load of 50 kilonewton axial both to the left and to the right. So we are asked to find the diameter of the link stock if the permissible tensile stress in the material is not to exceed 75 megapascal. That is, this is the allowable tensile stress in the crane. So before I go over the question, I will be recalling some parameters that we do know from our basic simple stresses and strain. First, we know that stress is nothing but force over cross-sectional area. That is, stress, which is sigma, denoted by sigma, is equal to force all over what? All over cross-sectional area. We also know that our area for a shape like this is nothing but pi all over 4 d square. This is our area. We also know that strain is nothing but what? It's nothing but change in length all over original length. So for this material, this strain will be what? The change in length all over the original length. So strain, denoted by epsilon, is equal to change in length all over original length. So this is what we have. So from here, of course, we can solve this question. So let's bring out our datas. We can say data given. Now, first we are given what? A load of 50 kilonewton. So our load P is equal to 50 kilonewton, which is the same thing as what? The same thing as 50 times 10 to the power of 3 newton. Secondly, we have a tensile stress of 75 megapascal. So our stress, sigma subscript T, will be equal to 75 times what? 75 times 10 to the power of 6 Pascal. Or we can express this, our sigma T will be equal to 75 Newton per millimeter square. So this is what we have. So now let's go over and solve the question. Now, to solve this question, first we need to calculate the area of this coil chain. We need to calculate the area. And how do we do that? Area is equal to pi all over 4 d square. So we can say area A is equal to pi all over 4 d square. Now, pi all over 4 is nothing but 0.7854. So area is equal to 0.7854 d square. So this is what we have as our area. Next, what do? Don't forget, we are asked to calculate the diameter of this link stock. So in order to calculate the diameter, we are going to be using the stress formula, because of course we have our value for our load, which is 50 kilonewton. We also have our stress, which is 75 newton per millimeter square. So we can substitute for our load, we can substitute for our area and our stress, and then we'll get the diameter. So let's do that. So we know that stress is equal to load all over area. Our stress here is 75 newton per millimeter. 75 newton per millimeter square will be equal to what? It will be equal to our load, and our load is 50 times 10 to the power of 3. So we have 50 times 10 to the power of 3. Our area here is 0.7854 d square. We have 0.7854 d square. So this is what we have. So from here, you can see that, of course, we can calculate our diameter. What do? We can cross multiply this. If we cross multiply, we are going to be having 75 multiplied by 0.7854 d square to be equal to 50 times 10 to the power of 3. So we have 50 times 10 to the power of 3. So this is what we have. We can further simplify by dividing both sides by the coefficient of d square. If we do that, we will have 75 times 0.7854. 75 times 0.7854. So this is what we have. Of course, this we go with this. We'll be left with d square to be equal to. Now, if you press your calculator, when we have 50 times 10 to the power of 3 all over 75 times 0.7854, it is nothing but 850. So if you solve this, you have 850. So d square is equal to 850. How do we get our value for d? We can square both sides to remove the square here, and then we'll have our value for d in millimeters. So if we square both sides, square we go with square. You agree with me that the square root of 850 is nothing but 29.13. So our d, which is our diameter, is equal to 29.13 millimeter. Or we can approximate and say our d is nothing but what? It's nothing but 30 millimeters. I hope you understand and comprehend this question fully. Stay tuned for more questions on simple stresses and strain. And also be sure to like, subscribe, and also comment if you have any comment on this problem we have just solved. Thank you for watching.